Shellheads. Welcome to the next phase of how I made my helmet wireless. In this phase, we're going to talk about the actual board that controls the helmet and makes it go up and down. Now, again, just like I said in the intro video or the first video, this is damn near verbatim what James Burton uses. So head on over to X Robots if you want a clearer explanation of this kind of stuff. But I'm going to do pretty rudimentary kind of talk about it. I'm not going to go over each part, but I am going to just show you how I put it together, and hopefully you can put the same thing together. Now, the next bit of material you're going to need is this Picaxe 08 proto board kit. Now, the other thing you're going to need is the Picaxe 08. This is the chip, should be right here, the chip that works with this board. They are sold separately, unfortunately, so you have to buy one board and one chip or more if you're going to do lots of these things. I recommend that because these actually have quite a few uses that you can do with them, and if you mess one up, then you have another to go back to. So that's my suggestion. Now again, there's kind of sort of instructions, as I often refer to them as. It's mainly just a contents list, and then on the board itself, now I'm going to try and get a little bit closer to the camera here, but on the board itself it actually says where each part goes with their little code or naming convention that they have with the contents list here. So we're just going to follow that, and this has far less parts for now, but we're actually going to be adding quite a bit more parts. Now, one of the contents of this packet is a set of wires for a 9-volt battery hookup. We don't need this, we don't want it, so we're going to toss it. What we do want is the battery pack that we intend on using. I use either these 3 AAA battery holders that I used in the switches or the RF transmitters, or the daisy chain that I made, like in the other, like on the receiver side. Now these are just one battery holders, or 1 AAA battery holders with a positive and a negative wire on them. I trimmed the negative and I trimmed the positive on the second battery pack, connected those together. Same thing with this side, negative to the positive, and then took the negative, added a longer negative wire to that, and stretched it across the whole thing to make one long daisy chain that I can bury up in the helmet. Okay, so that's our power for this. And the rest of it is just a few tiny little parts that we're just going to solder in real quick. There's only 2 resistors on this one, so we don't really need to do the whole list of organizing everything like we did in the previous videos. This is pretty straightforward, so we can just work off of this list. And Alright, and that is all there is to getting this ready to be programmed and to start adding our pieces to the prototype side of this board. The battery packs we're going to wire through this bottom section here. And the way we're going to do that is take the positive and negative sides together. We're going to push them down through the first hole, right on the edge there, back up through the second, get a loop there, and then loop them back down. Yep, we got them on the wrong side, so we're just going to swing these around a little bit. And slide these right into these holes here. It's marked red and black, so you can definitely identify where they go. And we're going to put them into place. We have a little bit of solder here. And that goes right into place. It's the redstone. Push it a little bit more. Sorry. Let's see, now we got solder on there. Let's try and push those a little bit tighter. There we go. And the positive as well. Okay. I'll shut that off. Done with that for now. Trim these as we do. Now that they're soldered into place, we can pull the wires back through, get them a little bit tight, and then finally tighten this loop up. Now it has a point of friction, so that if this gets pulled on a little bit, it's not going to pull the wires out. At least that's what I imagine it's for. But like I said, it gives it a nice point of friction so it can't pull back out. But now we have power to the board. We can take this and program it, but that'll be for another time. The next video, I'll start adding the rest of the parts to make this actually work. And let's see, I'll just start with that one. First thing we'll start with is the pull down resistor. Now these are the instructions off of Picaxe again, and again I'll link those in the description, but these are the microcontroller interfacing circuits. The circuit that we're going to follow is this one, the middle one here. This is the pull down resistor, so that we can put a switch into place. And we are not going to put a switch into place. What we are going to put is the line from our RF receiver, and that's actually going to act as our high signal to this pin and actually set this thing off. So that's what we'll work on next in the next video. It's only two resistors, a 1K and a 10K, and we're just going to position those on this board so that we have enough room to do everything else. And then we will also probably start working on putting pieces in place for the servo control. For that, you're going to need a 330 resistor and a 100 nanofarad capacitor. Again, I'll list everything that you need in the next video, all in the descriptions, so that you can go looking for these. I recommend ordering these as like packs. That's how I got them. I got a big pack of resistors. I don't have anything open right in front of me right now, but got a big pack of resistors, got a pack of capacitors, and that pretty much suited everything I've needed so far. So until next time, thanks for watching. Please like, subscribe, definitely keep following this if it's working out for you, which I hope it is. See you later.